first, what is automated testing? Considering the type of person I'm addressing, I assume you're all familiar with automated testing. I'm not going to explain why test an application or why it's good to not have build errors. I think you're all up to speed on that. So we test to automatically to reduce human intervention, to have some way to make sure that our project is reliable, even if we're not reviewing everything, essentially. So what is ZATS, Z-A-T-S? It's the ZK application test suite. It's a software framework that lets you easily test the business layer of a ZK page without having to bring too much baggage with you while doing so. You use it to test a ZK application without a server and without a browser. So you get less things to set up. You can use regular unit test structures. If you're familiar with JUnit or any other testing library, you can simply integrate your ZK tests in those. And we test to just simply avoid functional regressions whenever we make updates to a project. All of the code I'm going to show you today, everything I'm going to be displaying is available on GitHub. Again, you're going to have access to those slides. If you want to retrieve that URL, you can do it now, or you can get it from the slides later. Okay, so let's first talk about the general architecture of a ZK application. So this is not ZATS. This is a very simplified version of what a ZK application does just in production, for example. We start with the client browser. The client browser is what your user is going to be interacting with your page from. The browser sends page requests and sends user interaction to your server container. Your server container is going to be your Tomcat, your JT, whatever is running your servlet application. That servlet container is going to go to your content files, which are going to be your ZOL file and your Java classes that describe your ZK application. So that should be, in most cases, either a ZOL or a composer, or a ZOL file and a view model, which are generally what happens. There are other things you can test for. If you're using Richlet, you can also test Richlet with that. It's a bit off topic for this discussion, but just know it's possible. The servlet container with the data and the structure provided by your ZOL and your Java file is going to generate your page. And when sending updates, is going to generate the new state of the page and sends page update to the client browser. So why is it that we want to simplify this? So first, testing with a browser is annoying because in addition to the Java classes that you're going to try to verify, you also need to account for variation in browser, for network speeds, for all sort of little interaction that might get in the way of just making sure that your composer is working well. So the first step is going to be removing the browser. So we have our first simplified step. We test without the browser. We still have a server container because we need all of our servlet classes in order to generate the page, to process requests, and to update the state. So that's still not ideal because that means we need to boot up a servlet container. Depending on your application, it might be somewhere around 20 seconds for a very simple application. It can go into several minutes if you have a complex application with several containers interacting with each other. So if you just want to make sure that your latest commit is not breaking anything, it's kind of annoying to have to wait that time to just have functional testing happen. So second step, we remove the server and we only keep our ZOL file and our composer. However, a ZOL file and a composer does not make an application. So we still need a piece of software to read the data from the ZOL file and from the composer, and to generate page states that we can then query in order to verify whether or not our page is working. And that's going to be ZATS Mimic. ZATS Mimic is our servlet emulator that is part of the ZATS framework. What it does is it replaces your servlet container. It's going to be able to instantiate pages based on a ZOOL file and a composer. It's going to be able to send updates to those pages. So we're talking user interactions like clicks, selecting items, opening, closing different window inside of the container. Everything that a user can do, anything that can be sent from client side, ZATS can act as a proxy for. And on the output side of things, ZATS is going to let you look at your components, see how they've been modified by the user actions, and lets you verify that those modifications are what you expect. And if they are, you pass the test. If they're not, you fail the test, and you have a good information that something went wrong. Okay, so to finish on that introduction, to review what we've discussed so far, we're talking about pure Java testing. We're not talking about going into the browser and doing some JavaScript manipulation to retrieve value or to take picture of the browser. We're doing unit testing with known unit testing frameworks. So every best practice, every knowledge you have about your JUnit or any other testing suite that you're familiar with, you can bring it into ZATS testing and essentially apply exactly the same thing. We're doing logic validation. We're going to take your business class, that's your composer in most cases, and we're going to do events on them and verify that the result of those events are the modification that you expect, and then either pass the test or fail the test. And we're going to ignore the browser entirely because we're only interested in the data layer, not into the presentation in the browser window. All right. So now that we've discussed the general topic, let's get a little bit more on the architecture side of things and how to set it up. So just to repeat myself a little bit, JUnit, TestNG, any test framework you're familiar with, you can integrate with. Client emulation is what I already mentioned as well. You simulate events, you simulate clicks, selection, anything triggered by the user, and you verify that the state is correct at the end. I'm skipping a little bit over because I'm hammering those points home, making sure we're all on the same page at the start, so that when we get to the code, everything is smooth and nice. Okay, what are we testing? So that's an important question. If you're using MVVM in your application, your view model is already a POJO. If your view model is already a POJO, you do not interact with your view or any other layer of the application. So as a general rule, you don't need that to test a view model because a view model is already independent of other layers. You can just do a regular JUnit test on it and it's going to be fine. You change a value, you test if after changing that value, you get the result you expect. Where ZATS is very useful is in testing composers, because composers, as part of the MVC pattern, are very tied between the view and themselves. So you need that in order to mimic the view, to receive those events and to update the view so that you can make sure that the composer is performing accordingly. And as I already mentioned, ZATS is going to let you do that without having to run either a browser or an entire server behind it. Now that we've done through the abstract, we're going to build a test case together just to show you the building blocks of running ZATS, making sure that everything is clicking and then getting a test result at the end. So for this purpose, we're going to use a very, very, very simple application. Our very simple application, as described here, has a button, has a label, and when you click the button, you update the label. You just change the text. So the functional expectation is we're going to click our button, and the text of the label is going to go from empty to hello mimic. If the text is something other than hello mimic, something has gone wrong and we can fail the test. So before we actually create the test itself, we're going to need to set up our project for testing. In this case, I'm going to be using a Maven project, which is the ZATS example project available on GitHub on the link mentioned earlier. The setup for the project is very simple. In our scope test, we're going to add both our testing framework. So in this case, my testing framework is JUnit. And we're going to add ZATS Mimic, which is the ZK test suite extension that is going to be used inside of our unit test. Okay, let's go back to the slides. So to set our test case, we're going to do all of the following operations. We're going to set the path of our content being our ZUL file, which itself contains the composer, so we don't need to access the composer directly. We're going to create a emulated client, which is going to act as the browser and read the ZUL file. We're going to use a query selector to find components. We're going to mimic user interaction on those components, and we're going to check the result by looking at the component's property or field. So all of those code as well, you're going to find again on GitHub at the end of the training. So first, building our test case. The first thing we're going to do is to set the environment. The auto environment is a class that comes with the ZATS dependencies. So you don't need to create anything here. If you just want an auto environment that is going to read your web app folder, you can just give it the path of the web app folder inside of your project. If you have a different way to retrieve your documents because you're using a slightly different path to your web resources, you can just input the right path and then you're started. By default, ZATS will include a simple web.xml and zk.xml. So if you look at the code sample I'm showing right now, you can see that I'm not defining anything. That's because if you're not specifying it, you don't have to declare one out of the box. You get one already available. For ZK version, I'm currently on 9.6, but you can test any ZK version with that. That's all fine. You just choose your ZATS version accordingly. Okay. Once we have our environments, our emulated server, we can create a client. So in this case, an auto client is going to be generated as an emulated browser. This is going to take the role of our actual web page. It's going to send events, it's going to send updates, and we're going to be able to use it to make operations on our page. To note is important. Your auto environment is going to be part of, your auto client is going to have a session. If you open multiple desktop in the same auto environment, you will be able to simulate a case where the same user is going to access multiple pages, either from the same browser tab or from multiple tabs in the same browser environment, where all of those pages might interact with each other. So if you store something in a desktop, if you have that type of property that are going to be shared by multiple pages, you'll want to be in the same auto client. If you want every single one of your cases to be isolated, you're going to want to create one auto client per test. Okay, now that we have our fake browser, we're going to be able to do operations. And for that, we're going to use the desktop agent to retrieve components. We're going to do it this way. Once we've connected to our ZUL file, we're going to have our page loaded in our mockup desktop. And then we can use desktop query using the query selector syntax to retrieve objects from the page. So in this case, I'm using a class selector. So I'm retrieving buttons and label by their component name. But if you have IDs or S classes or any other selection supported by query, you can use those selectors to retrieve specific objects in the page. All right. Now that we have our button and our label, we can do things with them in order to actually test our workflow. So the first thing we're going to do is we're going to simulate a click on the button. We have two ways to do this. The easy way is to use the shortcut click, which is directly available on all component agents. The slightly less easy way is to transform our component agent into a click agent. A click agent is an operation agent that is going to mimic user interaction. In this case, it's specifically going to be used in order to make clicks, right clicks, double click, anything that has something to do with a click event. All right. And then our component agent is going to let us interact with those objects as if they were actual ZK component in a working application, in a production case. The component themselves can be used to look through their descendant. They also have access to query, and we can use that to access their field and their value. So what are we doing? We're clicking the button, and then we're doing an assert equals. If you're familiar with jQuery testing, sorry, jQuery, with brain damage. I cannot remember the name of my testing suite, but if you're familiar with JUnit, there we go. With JUnit testing, you will note that assert equals is the function that we call in order to make a statement and to either be true or false, make the test pass or make the test fail accordingly. Thank you. Yeah, JUnit, exactly. And so here we're finding our label component agent. We're passing it into a specialized label class, which is going to let us access all of the function available to a label component. And in this case, we're going to do get value, which is the text of the label, and verify that it is equal to the hello mimic text that we expect it to be. All right. Once we're done, that's basically it. We have a test case, and we can just run it. So because we did not declare a configured path to a webinf or a WebXML, we're going to use the default one from the ZATS suite. So if you have any specific properties, library properties, or WebXML settings that you need to use in order to match your actual production case, stay tuned. We're going to talk about that a little bit later. What does that do? That creates a self-contained context only for that test. Spinning it up, spinning it down for the entire test. In this case, I run it as part of a test series. So I only started the JT environment once, sorry, the Maven environment once, and just doing that specific test gave me a 0.3 second test speed, which is fairly reasonable. It might be a little bit more or a little bit less depending on your clock speed or depending on the complexity of your test, but you should expect to be well under the minute mark when doing tests that way, which is not easy to achieve if you were spinning an entire server. And you can read the result of your test as you would read the result of a regular unit test. So just to run it locally, to give you an idea, let me find my PowerShell here. So in this case, I'm just going to run it as a Maven test. You were probably familiar with Maven testing. I'm using the test argument here, test parameter, to tell it to run that one specific test instead of all of the tests that are available in my project. And when I run it, it's going to do its thing. Maven is going to just run its startup, is going to find my test plugin, start testing, spin up my Hello test environment, get the fake browser and the fake server ready, perform testing, close the environment, and here we go. We have one test run, which is expressed as test run, failure errors, skipped. If there's no error, we have a build success, and you can open that. You can exploit that through a Jenkins or any other CI/CD environment that you're already familiar with. Okay, for the easy part, that's about it. Now we're going to talk about a few advanced topics. If you have an interest, I encourage you to stay for those, and we're going to do the Q&A at the end. Okay, so a few advanced topics. I mentioned that you can use your component agent with the as method in order to obtain different user interactions. Here's a list of all of your available user interaction, which notably contain your click, your input, your select, etc., etc. It also contains a custom operation agent. This one is very interesting if you are using any custom code, because if you fire a custom event, for example, you can still test that. If you expect your browser to send you a on my custom drag or on my custom select or whatever JS customization you may have in your project, you just use a custom operation and you enter the different part of the ZKAU request that you expect to see, and the custom operation is going to build that for you and send it to the composer. We're going to skip over to why you would want to use the interaction cast. It's not casting, but think of it as casting the class. It will gives you access to autocomplete in your IDE. So to give you a simple example of that, if I go back to my test case over here, I'm going to be able to go to this click by using this syntax instead of the click shortcut. You can see that I'm using button as a click agent. Because it is a click agent, the IDE is going to be able to provide a little bit of help for me. So I can see that a click agent have access to click, to double click, to right click also, I believe. It should be somewhere in there. Right click is here, yeah. And with that way, I have a very easy way to select the operation that I want to mimic. Okay, the other thing with that, we can also use this with ZK component classes. So in this case, you can see I'm using label as, in this case, as a component agent representing a label. This is going to give me access to all of the methods that are normally accessible to a label. So in this case, I was using the get value, but if I want to check anything else, I will be able to retrieve all of those different getter setters or actionable method that might exist on my component. If I go to give a better example, if I go and check, for example, a checkbox class, I will be able to find things, for example, is checked or is disabled, which are not unique but specific to the checkbox class. All right. I believe that's clear enough on those two. We can go to a little bit more detail into environment configuration. So I mentioned earlier that by default, ZATS is going to use a very simple zk.xml and web.xml that are already provided by the ZATS environment. That might not work for you. You might have library properties to enable or disable specific part of ZK features. You might have custom items in your WebXML, AU extensions, anything that might change how ZK processes your different events. In that case, you would pass a custom webinf path to your default ZATS environment. You might also want to set a context path. So by default, ZATS is going to assume that there is no context path, and the context is just going to be localhost/. If you want to be localhost/my app instead, because that's what you're using for testing and that's what your composer expect, you can add a context path parameter to your default ZATS environment instantiation call, and voila, that's it. And then when you init your environment, you can still give it the correct path to your files, and you're done. A few important details, especially regarding Springs or other way to manage your beans. Because there is actually not a servlet container behind ZATS, and because Spring Beans might need to be in a servlet container to function correctly, if you're going to try and auto-wire some beans into your composer, you're going to have to set up a Spring context manually in your WebXML. So in that case, just see above, put your WebXML, put your zk.xml, and do your configuration that way. It's a bit off topic to go further in detail, but if you have any question, let us know, and we can always send you a message in answer. All right, and let's talk a little bit about some limitation and the side topic of browser-side testing. So, because we're not running a server, anything that is server context dependent is not going to work. If you're going to try and use GNDI, GTA, this kind of thing, well, you're going to have to run a server. Essentially, ZATS is not going to be able to help you on that, because the entire point is to not have that entire servlet container behind you, to streamline it and to get things faster. If you're going to want to try and get some browser-side testing, because you want to check animation speed, because you want to check the look and feel of the page, maybe take some screenshot and send your screenshot at the end of your test cycle, you're not going to be able to do that with ZATS either. That's also out of scope. We're getting rid of the browser very much on purpose here. However, just to mention browser-side testing, you can test a ZK application with browser-side testing tools. The classic is going to be Selenium. There are other testing suites that are going to be workable here too. And since we're talking about testing, I'm going to bring up a few sticking points for browser testing that are completely out of scope for ZATS, but I know those come up fairly often, so I'll just address it quickly in case that's of interest to any one of you. So first is the topic of static UUIDs. If you've ever looked at the client page for a ZK page, you'll know that all of your DOM elements have randomized IDs. That is on purpose, both for consistency, security, for a number of reasons. ZK by default is going to create random UUIDs for every one of your components. That might be annoying if you try to retrieve a component with Selenium, with a jQuery selector, because you cannot easily find the ID of the component. So how do you address that? ZK has, I believe, since ZK 8, but don't quote me on that. It's in the documentation page. ZK has a static ID generator. So if you're going to try and select by ID, just go to the ZK documentation, find the static ID generator, put that in your zk.xml, and now all of your ZK pages, as long as you do not change the page structure, are going to be generated with the same UUIDs. The other option is to implement your own. You can set your own ID generator class, put it into your ZK XML in the proper configuration block, and just generate your own IDs. Maybe you have an attribute that you know about your component, and you want to put that into the ID to be able to select from it. As long as you don't create any duplicated UUID at client side, you will be fine. The other thing you can do is disable UUID recycling. ZK will attempt to reuse UUIDs when a component is no longer part of the page, just to streamline a few things under the hood. You can just disable that in ZK XML as well. There is a property that is going to let you do it. So if you just want to make sure that you have exactly the same page every time you open it, every time you do an operation of it, disabling UUID recycling is going to help you. And finally, the last thing, if you don't want to disable random UUIDs, you can just use ZK selectors. When you set an ID on a ZK component, you can use a ZK $selector in order to retrieve a client-side widget by that ID instead of the UUID. I invite you to go to the documentation page regarding client-side selection in ZK if you want more information about that. And with that, we're getting close to the end. So before we go to the actual Q&A, just some links if you want to read a little bit more about ZATS, or if you want to run the example project that I've been using today, which has a lot more test cases, a lot more example than the one I've been just displaying. You will be able to find all of those are at the following links. As I mentioned, you're going to have the slides available once the recording is available as well. All right. Q&A. Before we do Q&A, one question. If you're not staying for the Q&A, we'd be interested in learning about what interests you. We do training every so often. If there is any topic that would be of interest to you, on which you feel having a little bit of insider knowledge on how ZK does things, or any specific topic that we've not covered in a while, let us know. We might actually pick up the ID and make a training on that. Okay, so while you answer that, let's jump into the Q&A. I see we already have one question. Is it possible to know if UI graphic rendering is done correctly? Not with that. We don't do browser testing with that. As I mentioned, you can test the UI in a ZK application. In that case, Selenium is going to be the classic choice to do that. The last slide I've mentioned had a few tips, but if you're interested in Selenium testing, we also have some extra info in our documentation. With that specifically, we don't have a browser, so we only care about the logic of the composer itself. This integration test is only doing your event without UI rendering. That's correct. Yes. And also question, is it possible to do UI test in live production at started or programmatically? I think it is. You can run a Selenium test on anything that has a browser page attached to it. I think doing it during integration or development makes more sense than do it in production, but nothing is stopping you from giving the production URL to your Selenium test cases and having it run. I will say if you're going to put test-specific configuration, so for example, disabling UID recycling, disabling randomized UIDs, I'd suggest you do that in a development environment instead, and just have that re-enabled at production level. UI testing tool often recommend to use custom attributes like data XXX and then get data XXX click. No need to worry about ID. It's also a possibility. In ZK, you can set custom attributes directly. The ZK component class, the abstract components, has a set custom attribute. You can put any arbitrary DOM value that you want and test that way. You can also test with jQuery selector with the ID. I mention it because it's a question we get fairly often. It seems a lot of people are still testing with IDs. Yeah, there are also advanced things you can do. If you want to put those component custom attribute in Zool, you can use the client namespace in Zool in order to the client attribute namespace in order to directly put a value from a Zool component directly into the DOM element associated with it. And you can use also the onBind client event listener to get access to a little bit of a JavaScript event callback that occurs when the ZK DOM element get initialized. In which case you can do all sort of things directly in JavaScript, and use that as the anchor for your testing. Okay, let's see. Can ZATS be used for load testing, starting multiple tests on parallel? Yes and no. You can have multiple tests occurring in parallel, but that's not going to really be a great indicator of how an actual server is going to run, specifically because we're not running a server, which is the entire point of that. If you're going to try and get a good idea of your resource consumption, of your of the delay you might get when you've got 30, 50, 100 plus users, I'd say it would be more worth it to just spin an actual environment up, because then you will be much more closer to what you should expect to see in production. That does not have network delays because we pretend to be a browser, but we're not actually one. ZATS does not have a servlet backend. So anything that might be related to your servlet or to your other frameworks that might be running into the same container is not going to be there when you run a ZATS test. So for load testing specifically, while you technically can run several tests in parallel, it's not going to give you the information that you want. I think we're out on the question and feedbacks. So with that, have a good day, everyone. Thank you for coming, and hope that was an interesting topic for you. Goodbye.